Did you know that if you add, subtract, or multiply an integer, the result will always be an integer? However, if you divide an integer, your result will either be an integer or a fraction. My name is Miss Chelsea, and today I'm going to be talking to you a little bit about integers as well as how mealtime stories are used to represent integers. First, what we're going to look at is what is an integer. So here is a list of what integers are. We have whole numbers, and here inside the brackets you see that whole numbers mean 0, 1, 2, 3, and so on to infinity. Natural numbers or positive integers are going to be numbers such as 1, 2, 3, and 4. We have negative integers, and here in the brackets that shows us that -1, -2, -3, -4, all the way to infinity is going to be an integer as well. And then we have just this inside this little bracket here, it shows us what all integers are. So it's going to be negative infinity all the way to positive infinity. And 0 is included in that, so 0 is an integer. Over here, it just gives us examples of what integers are, which is what we just talked about, and then also what numbers are not considered integers. So we have numbers that are decimals and fractions. So 5.9, 7 over 5, 45.2, and 8 over 2. Those are not going to be an integer. Next, we will see how we use integers in real life. More commonly, we do use integers every day. We don't think about them as integers. We think about it as our money or as stock market gains or the distance above sea level, yards gained in football, and things like that. Then the negative numbers, you would represent things such as yards lost in a football game or football play, distance below sea level, money that you take out of your bank account, things like that. So this other example I have here on the right side, it's basically the same statements as listed in this example, except it gives us a number to kind of correlate those statements with numbers. So number 1, a football team lost 5 yards on their last play. -5 would represent 5 yards lost. A football team gained 12 yards. A +12 would represent gaining 12 yards. I deposited $400 into my bank account. 400, a +400 would represent depositing $400. So you're putting in $400. If you withdraw or take out $298 from your bank, it would be represented as a -298. And number 5 here shows it is 17 below 0 outside today. So that would be represented by a -17. And then it is 45 degrees outside today. That would be represented by a positive number, so it would be 45. And here is how we use mealtime representation to represent integers. So we're going to get a statement here. It'll give us a number. And this one says 27 plus -48. What you're going to do is you're going to look at each individual part of the problem given. So for this one, we'll look at the 27, which is a +27. That means that the mail carrier will be bringing a check to you for $27. Next, we'll look at the sign in the middle of your problem, which this one has a positive, so a plus sign. That means that he will be bringing you something as well. If it is a minus sign, that means he will be taking something away. So then we'll look at the last portion of the problem here, which is a -48. So that means he's also bringing you a bill. If it is a negative, that means that it will be a bill. And if it is a positive, that means it will be a check. So let's look at the second portion of this problem here. It shows 27 minus a -48. So the +27 at the beginning of the problem means a check. He will be bringing you a check. The minus sign means he will be taking away something, and the -48 means a bill. So he will be taking away a bill for $48. Next, I have just a few more examples like the ones we just looked at, except they changed the sign up here a little bit, so that way you'll be able to just kind of look and understand different ways that you can have different problems and how you will be writing them out. So for this first problem, we have a -27. So that means he is bringing a bill for $27. The plus sign in the middle means he's also bringing something else. And the +48 means he's going to be bringing a check for 48. And the second problem shows here that -27 means he's bringing a bill. So the mail carrier, sorry about that, will be bringing you a bill for $27. then he's going to be taking away a check for $48. So then the way we look at this is the actual problem as a whole, the negative 27 minus 48. If you actually work that problem out, just the numbers without having a statement, it would be 75. You'd be poorer by $75. So you would also be looking at this problem to know what the net worth is, if it's going to be increasing or decreasing. So that's why you see richer by $21 here and then poorer by 75. And I hope that this presentation has helped you understand how mealtime stories are used to represent integers. Next, Ms. Akeisha will be going over number line representation of integers with you. Thank you.
Thank you, Ms. Chelsea, and thank you for teaching us about mealtime representing integers. I'm going to be teaching about number lines representing our integers. So she gave us some great examples on what an integer is. And another way to think about it is that they are counting numbers. So think of a rocket ship, and you're going to count down. So -9, or 9, 8, 7, 6, 5, all so forth, all the way to blast off. And then you can go 1, 2, 3, 4, 5. You're going backwards and forwards, and in reality, you're not going to do that. You're going to go forwards from -9, -8, -7, -6, and so forth, all the way, and whatever number you want. Number lines are lines. So if you remember, if there's an arrow on each end, they're going to go on forever. Negative infinity all the way up until positive infinity. So if you look at this number line, anything to the right is going to be positive. Anything to the left is going to be negative. And that goes for when you're moving on number lines. So if you go move to the right, positive. Move to the left, negative. And that's going to bring me to my next point of jumping across number lines. Where's my mouse? There it is. Okay, here we go. So, thinking about jumping on number lines is it's math. So, you have two terms to think about here. Position is where you're starting from. And then your jump is the process of you moving. So, we're at 4. And I'm going to move 7 spots to the left. So, -7. And if you see that, it's going to take you all the way down to -3. The same as if I go from -5 to the right, 2. Start at your position of -5, go 2 spots, and you get -3 again. So even though 5 is a bigger number than 3, it still means that 5 is less than 3 because it's to the left on the number line. Does that make sense? So now we're going to go on to a trickier subject of absolute values. It may seem trickier since you just got used to negatives and positive integers, but absolute, it's taking away all those negatives. No matter what, it's going to be positive. So let's get our handy dandy little pencil out. And whereas jumping, you were doing math to get from point A to point B. absolute value is you're measuring the jump itself. So if you start at a position of 4 and go to the left to -1, you're going to think of these people as people in a conga line. Don't want negative people. That makes it no fun. You're going to have positive people. So you got 1 person, 2 persons, 3, 4, and 5. So really, the absolute value of 4 going to the left, so minus, we ended at -1. So 4 minus -1 is 5. You always have an absolute value of 5 spots. If you want to draw that last little person. And the same goes and if you go in the other direction. So start at -5 and we're going to go all the way to 4. So yeah, add that 4. Anything inside the absolute little value bars is going to be positive. So in reality, you have 5 plus 4, giving you 9 little positive spots. I hope that you have a better understanding about integers, number lines, and even absolute values on number lines. Thank you so much for watching. Let's dance on out of here.